Welcome to the second video of this transmission line problem solving series. So, in this video we will be solving this particular problem. So, what this I will solve with problem as formula as well as Smith chart as well. So, both ways we will see. So, you can choose which way you can. So, if it comes in your university exams, you can choose any way to solve it, either Smith chart or based on formula. Both are easy. So, what it says? It's saying that a transmission line is there. So, there is a transmission line and whose length is 30 meter long. Okay. So, make sure whenever problem any length is given, so all the transmission line calculations are based on the unit, that is meter is taken, not centimeter. So, make sure that whenever any length is given, so you convert that to meter. If meter is given, you can directly use. Okay. Now, it is saying that the Z0 is given, characteristic impedance is given as 50 ohm, and frequency of operation is given as 2 megahertz and terminated with a ZL. So, here one load is connected and the ZL value is given as 60 plus J40 ohm. So, that is what is given, and the velocity in the of the wave in the transmission line is given as 0.6 c. So, these are the data given, and it is first is asking what is the reflection coefficient, what is the standing wave ratio and the input impedance. Okay. Now, let us solve the first one. So, first we have to find the gamma value, that is the reflection coefficient. Now, to find that, which formula to use the reflection coefficient, you can see lossless transmission line is given, and for lossless transmission line the reflection coefficient is equals to ZL minus Z0 divided by ZL plus Z0. So, that is equals to ZL is how much? ZL is given here. So, it is 60 plus J40 minus Z0 is given as 50 and divided by again 60 plus J40 and Z0 is given as 50. Okay. So, with this calculation it will be around 10 plus J40, 50 minus 60, 60 minus 50, and 110 plus J40. So, if I calculate this, so this should it will come as a complex number x plus iy, or j, the complex number will come. So, reflection coefficient is always represented as its magnitude and the angle. So, you have to represent the magnitude and the angle as well. 0.3523 with angle of 56 degrees. Okay. So, this is the answer to bit 1. And second is, it is asking the standing wave ratio. Very simple formula. It is 1 plus magnitude of gamma divided by 1 minus magnitude of gamma. So, remember only magnitude has to be taken. So, that is equals to 1 plus 3523. So, this is the magnitude divided by 1 minus 0.3523. Okay. So, with calculation this value will come as 2.088. Okay. So, this is the SWR. Next point is to find the input impedance. So, the input impedance we can use the standard formula. So, what is the standard formula? Let us write that first and we will see what needs to be calculated. So, standard formula, or that is the input impedance Z in, is equals to, so Z0 into ZL plus JZ0 tan beta L divided by Z0 plus J into ZL tan beta L. So, here hyperbolic is not used because in the question already it is given that it is lossless line. So, that is why here alpha is equals to 0 and his gamma is represented as 0 plus J beta. So, that is only beta here, right, J beta here. So, that is why hyperbolic term is not there. Now, here first we need to find the beta L value, then we can directly calculate this. So, we know that beta value is equals to omega by velocity. Okay. And what will be beta L? So, beta L will be equals to omega into L divided by velocity. So, velocity is given as, here you can see velocity is given as 0.6 into c. So, we can write beta is equals to, so omega is how much? So, frequency is given, we know that omega equals to 2 pi f, right. So, here omega you can write 2 pi into frequency, that is given 2 megahertz. So, 10 to the power 6 okay, into L. L is given as 30 meters, right. So directly I can use the value, and divided by 0.6 into c. C means here speed of light. So speed of light is what? 3 into 10 power 8 meter per second. So this is coming as 120 degree. So this value will come as omega is used here, it will come in radians, and then you can convert that to degrees. Okay, so that value will actually come as 2 pi by 3 as radians, and you can convert that to degree, it will come as 120 degree. Because this we can directly use here, you can use 2 pi by 3 as well in the formula, but make sure that your calculator mode is in the radian mode. If your calculator mode is in the degree mode, then you have to use this one. So that's what you need to take care. So here you can use the value. So Z0 is given as 50 into ZL is given as 60 plus J40 plus J into 50, that is your Z0, and into tan of 120 divided by, so again 50 plus Z0 plus so ZL 60 plus J40, and this is multiplied with J tan of 120 degree. So you can make the calculations. So this Z will come as 23.97 plus J 1.35 ohm. Okay, so now this is the answer. So when Z in is there, you need to represent as a x plus iy form, and if gamma I value is there, the complex form has to be presented in magnitude and angle form. This is the standard representation, and make sure that you use the ohm here. Okay, so this much from this is the video. This video ends here, the solving this with the formula, and in the next video will be I'll use the Smith chart to solve the same problem again. Okay, so let's meet in the next video. Thank you.